Hello everyone, welcome to this live stream. I am late by 20 minutes, so I do apologize, but basically, wait, let me just say it on Instagram as well that I'm live streaming. But yeah, 11 to 12 or 11 to 1, I haven't decided yet. Every single Saturday, live stream. Welcome to the live stream. Live study with me welcome every Saturday at 11. Yay! Thank you for the thumbs up and thank you for joining me. Let me post this on Instagram so I can set up my Pomodoro timer. Like always, I am using Flipped. Let me end this Flip session actually so I can start a new Flip session. But yeah, I'm an affiliate with Flipped, so I always use them. But I obviously have to disclose that all the time. And now they have a new thing. I don't know if you can see that, where it says Pomodoro. So we're going to do that. I'm trying to think, is this a good angle? Oh yeah, in the background, you guys can just see. I have a softbox in case it gets dark. I feel like that's a solution because last time, sorry, I'm wearing my dad's hat. But that's a solution because like the last time I did my live streams, like in November, like the lighting was really bad. So we've got a big softbox up there. And yeah, I hope you guys are all okay. I'm just looking at the thumbnail. I don't even think you guys can see that. But it's a cute thumbnail for this. I just need to, upload it or whatever. But we are going to do some AS chemistry. So let me have a look and get it open. Teams, oh, I'll have my caps lock on still from writing a title. Comment what you guys are going to be studying. I don't want to use my Muji pen. And I love my Muji pens. I was like, should I get them? Were they overhyped? For a very long time, I was like, Muji. It's overhyped, but it's actually worth it, especially if you do like chemistry for curly arrows and organic chemistry. For maths, it's just nice when you have like fractions on top of fractions, when you're doing like partial fractions, and then you mix that with like binomials or something like that. Like these are really, really lovely. Not really beneficial in biology, to be honest, but it's really cute. Only downside is you can't highlight straight after you use the Muji. So I highlight before I use the Muji. But anyway, I'm rambling. I'm going to use my Inkjoy Papermate 1.0 for the chemistry today. And chemistry is obviously purple, so let me put on my watch actually so that you guys, I don't have to keep asking Siri what time it is. I mean, I'm still going to do it anyway because I probably will forget, but I'm wearing my watch. But yeah, so I'm using the Stabilo Original Pastel Purple to write a lovely title. We're going to start off with atomic structure, then we're going to do amount of substance and bonding, definitely. If I'm feeling it, we might do kinetics and energetics as well. I don't want to do too much in one day, and I don't know how big these exam packs are. This is the wrong chemistry class, year 13 chemistry, there we go. Did she say that's more homework? Files. Past papers by topic. We're going to do the questions from 2012 to 2018 now, so that when I go back to school, I will do the questions from 2015. Thank you for the thumbs up. 2015 to 2018 later on. So we're doing year 12 content today. So AS, let's open questions, not mark schemes. Atomic structure. That is the first chapter of the A level in chemistry. Should I get the mark scheme as well? Let's see how long these questions are. Maybe I should have looked at them before the live stream started. Ooh, that's quite a lot of questions. Oh wow, 14 questions, krypton, everything. Okay, 14 questions, probably 140 marks, but we'll see. We'll see how much of it I can do. Thank you for joining, as always. So this is AS. So let me write a title and then we can get to the questions. How do I write my titles normally? I completely forgot. Atomic structure. Atomic structure exam questions. And this is chapter 1. Do I put chapter 1 or do I? Let me write AS here in the corner so it's easy for me to identify, even though it's very obviously not a year 13 topic. Hey Raina. So let me write year 12 in the corner. I'm still trying to work out. Hello Ace Math. This whole live streaming thing, like I've been looking at different things to use alongside YouTube to help make it like more professional, so you guys can see from top what I'm writing. Don't know how much of that you can see, but let's get to the questions. These are all AQA questions. Let me just write 2012 the 2015 exam questions. What subjects are you guys doing right now? Obviously doing chemistry. This question is about the elements of period 3 in the periodic table. Period, that's across. State the element with the highest melting point and explain your answer. Let's open up a periodic table. So you know what, instead of a periodic table, let's open up a data sheet, because that way we will have everything from NMR for all the organic analysis. So I don't have to keep opening more tabs and stressing out this poor device. I'm going to click on the A-level data sheet, even though it's the AS one that I need, purely because the periodic table will be in there as well. Oh no, I opened up my periodic table in a new tab. Oh gosh, what have I done? I've lost the live stream. Where are you guys? I've lost you. I can still see a green flashing light, so I'm live streaming somewhere. I can't even come and see what you guys are saying. Okay, boom. Periodic table here, Teams here, live stream here. Awesome. So let's start off. Let me put the periodic table. Oh, yeah, periodic table is next to what I need. So period 3, 1, 2, 3. Who has the highest melting point? Element and explanation. Right. Everything's still loading. Loading. Is that the question? Okay, so where's period 3? So silicon is going to have the highest melting point, and that's because of the bonding. Yeah. Covalent bonds. Covalent bonds are many and need lots of energy to break them. Boom, Bob's your uncle. Now B, next question. State the element in period 3 that has the highest first ionization energy and explain why. That is going to be argon, because it has the highest nuclear charge with the same amount of shielding as well. When I work out how to do this live streaming better, I think what would be so cool is to do like a past paper, so you guys can see the paper whilst I'm going through the paper as well. But we'll see how that goes. So part C, suggest the element in period 3 that has the highest electronegativity. That's going to be chlorine. Argon is a noble gas, so it's inert. There we go. It's inert, so it's not going to do anything. Yeah, it's not going to make covalent bonds, so it has to be chlorine because that is the furthest to the right. Great. Part D. Chlorine is a period 3 element. Chlorine forms 2 molecules. It forms ClF3 and it also forms CCl2. Use your understanding of electron pair repulsion. This is chapter 3 in a question 1 book, chapter 1 booklet, but okay. Draw the shapes of them. Include any lone pairs. Okay. Well, you didn't leave any space in the booklet, but luckily I'm doing it on paper. So let's look at the periodic table and go through this slowly. Chlorine is going to have one of these electrons here. Fluorine. Oh, I'm confused. Chlorine needs to lose. No, sorry. Chlorine needs to gain 1. And fluorine also needs to gain 1. Wait, I'm very confused. I'm getting myself very, very confused. ClF3. So chlorine is going to be in the middle. Is it going to be like... Wait, so there's going to be a pair with chlorine and fluorine. And then is it just going to be like... Not even dative, like how will ClF3 work? Like, will there be lone pairs of electrons? I'm very, very confused. Like, how many bonds are in the valence shell of chlorine? Because this is a very simple thing. I think I'm overthinking it. I've not done any AS content in a long time. There are going to be 7 electrons in the outer shell. Okay, So we're going to have 7. 1, 2, 3, 4, 5, 6, 7. We have 3 fluorines on top, which gets us to 10. So we have 5 pairs. We don't have 5 pairs. We're going to have like 2 lone pairs, are we not? Yeah, because F3, 1, 2, 3, and then 2 lone pairs. Okay, I'm overthinking this. I'm really, really overthinking this. Breathe, relax. It's not that hard. So that's going to be 1 fluorine. That's going to be 2 fluorine. So wait, chlorine. We're having 2 lone pairs. 1, 2. Thank God it's not a dot and cross, but I'm getting a little confuddled. 1, 2, 3, 4, 5, 6, 7. Okay, just counting. Boom. 1 lone pair here, 1 lone pair here. Don't know why this is taking so long. So we have 2 lone pairs and we have 3 bonded pairs. So it's going to be like a B-Tech version of, wait, those 2 are going to repel. That's going to be there. Those are going to be like this. Okay. This is so lovely. Me struggling with the year 12 question. So I've not covered this content in donkey years. Is it donkey years? Dog years? How do you do it? Welcome to everyone who joined the live stream. Is it donkey years? I don't even know how that phrase goes. But yeah, let's go right back to the beginning. How can I be struggling with the year 12 question? This is my lovely geometry, page 28. I know you guys are thinking, babes, why are you looking at this revision guide when you don't endorse these revision guides? Because I just need something very simple to start off with. So 5 electron pairs. It's going to be T-shaped because it has 2 lone pairs, and it's going to have a bond angle of 88 degrees because lone pairs, hello Margaret Addo, lone pairs have their own repulsion of 2 or 2.5 degrees, right? I don't know what this particular thing says, but I tend to go for 2 degrees of additional repulsion, which would make sense. They don't think this and this. Oh, they've gone for 3 degrees here, but then I can't be this confused. It's additional repulsion. So instead of being playing out with 180, we've gone all the way down to 104.5 for water. Safi Ahmed. Hey! It's the fact that this doesn't even say. This revision guide has completely not mentioned this. It's just gone to a completely separate topic. Thank you for all the thumbs up, and thank you for everyone for joining. What are the lone pairs doing? Because I always say 2 or 2.5 degrees, but it's not telling me here. Do I have to open the textbook? This is meant to be chapter 3, and I'm doing a booklet on chapter 1 questions. I'm not very pleased because I want consistency in the topics that we are doing. Okay, so this is, oh, that's Hess's law, bonding. I just need someone to write down a simple number for me. I'm not asking for a lot, guys. Just a simple number. Have they written the number as words? Each pair, isn't it like a separate valence shell electron repulsion theory? But you guys, you're not telling me what I'm looking for. Tetrahedral, great. This is not showing any lone pairs right now. Ammonia, lovely. Repulsion increases, okay. Where do we start talking about lone pair? Here we go. So the textbook says 2 degrees, so I'm going to stick with 2 degrees instead of 2.5 degrees. Lovely. I don't know why I spent so much time looking for that. But yes, we're going to stick with 2 degrees. I feel like I should make some type of cheat sheet for each chapter, but right now I just want to get the questions done because I've spent how long? How long have we been on live stream? I've spent 14 minutes on a year 12 question at my big age. Okay. So this is going to be bent then. Oh, it's asking for 2 different shapes. You gotta be kidding me. Okay. So CLF3, that's going to be bent. Is it bent? T-shaped. I knew what I meant. Right. CL is here. F, F, F. I actually want to. One thing one thing that I do is I will have sticky notes with me so I can write questions at the end of things I've been confused of. Then I'll go through the textbook, YouTube, all of that lovely stuff. Still don't understand, then I will email my teachers. My teachers get a lot of emails from me all the time. Sorry. I need to get them lovely presents when I leave because, to be honest, I think I email them on a daily basis, if not every other day. So the first question I have is T-shaped chapter 3. Oh, and the reason I go by chapters rather than anything else is because I can remember what teacher taught me what chapter, because if I send an email and I send it to the wrong teacher, for example, they'll say, oh, that's not my set of spec, etc., etc. But anyway, also, this mark scheme have drawn their lone pairs really weird, and it makes me uncomfortable, but I can't do anything about it. I'm just not very happy with it. Anyway, so the next one is CCl2. Carbon. Where's my periodic table so I can have a good look at carbon? I feel like we have carbon so much. So carbon has 4 electrons in its outer shell. We're adding 2 chlorines. So we have 2 bonding pairs and 1 lone pair. I'm sure that looked very strange. Josephine Adam, hello. I feel like I've already said hello, but in case I haven't said hello, hello. So yeah, bonding pair, lone pair. Also, look, I finally found, since I moved like over a year ago now, I finally found Jaden, the skeleton. And obviously, I feel like you guys haven't seen Jordan in a while because he used to be part of the background when I used to film. I'm sorry that his intestines are falling out. Let me give him some privacy, some dignity, but Jordan is here as well, so that's nice. And obviously the periodic table is back to match the periodic table bed sheets. I'm rambling, but yeah, that's just something that I really like. I'm very happy I found that poster again, but I digress. Okay, so 1 lone pair. So it's going to be bent, is it? Lone pair here, CL here, CL here. That took way too much time. Okay, name the shape of CCl2, bent. Write the equation to show the formation. You guys are really asking me to do a lot of work. This is bent. So half Cl2 plus 3/2 F2. This is looking like maths, guys. I didn't sign up for this. Okay, let's go through the mark scheme. Uno, dos, tres, quatre. That's 4 marks. Do you know how much work I put into this for 4 marks? Where's my content? That's one thing about the chemistry mark scheme, especially the multiple choice section. I'm doing so much work for 4 marks. 1 mark, 2 mark, 3 mark, 4 mark. 5 mark, 6, 7, 8, 9. 9 out of 9, even though it took way too long. It should have not taken this long. Anyway, let's do question 5. Yay! Question 5. Question 2. Why do I think I'm so far down this? Tellurium is an element with the atomic number of 52. Using information from the periodic table, complete the electron configuration of tellurium starting with krypton in square brackets. Is that krypton, KR? Am I making that up? I feel like it's krypton. Yeah, it's krypton. I don't want to make up elements. That would not be a cute look. Atomic number is different to mass number, so we're looking at the atomic number. Krypton is atomic number 36. Oh, you guys are making me write a lot. 52 take away 36. So we have 16 electrons to account for. That's an awful lot of electrons to account for, but okay, I can do that. So 5s2, wait, yeah, 4d10, 5p4. That's the additional 16 electrons. Yeah, that's a lot of electrons, guys. Why do I sound so bitter about the electrons? The electrons haven't done anything to hurt me. So the mass spectrum of a sample of tellurium is shown in the graph. Use the graph to calculate the relative atomic mass of this sample of tellurium. Give your number to 1 decimal place. Okay. So let me zoom in so I can see the graph really nicely. 1, 2, 3, 4, 5, 6, 7. So the total is going to be 7. Is it going to be 7? I think it's going to be 19. 2 plus 7 is 9, plus 10 is 19. Yeah, it's going to be out of 19. I remember. I remember now because Emily showed me how to do this question. So 2 times 124 plus 1, 2, 3, 4. 4 times 126 plus 7 times 128 plus 6 times 130 all over 19 is going to be my answer, which is, do I use my calculator? I thought I lost my calculator. I was so upset. I was like, ooh, that's 127. You know? Yeah, 127.8. Lovely, lovely. So part II is address what might cause the relative atomic mass of this sample to be different from the relative atomic mass given in the periodic table. It's to do with the isotopes, right? Some isotopes. Oh. Isotopes. Let me check to see if the lighting is okay because it's gotten quite dark now. Let me put on my softbox. Whoa. Let me put on my softbox. Whoa, why am I shaking my desk so much? Does this help? Ta-da! Here's my fake sun to illuminate. I use my softbox a lot actually. Like if I'm ever doing a video call or something, I feel like it's not done much to help. But it's at least a little bit. And it's also gotten really cold. I've closed my window. But it's like, it's freezing cold. Let me grab a blanket. Because I'm shivering away here and I can't shiver and do chemistry at the same time. That is not very productive studying. Boom. Nice and comfortable. Let's continue with this question on isotopes and abundances. And thank you everyone for the thumbs up. I really appreciate that. Write an equation for the reaction that happens when tellurium ions hit the detector. I'm going to be honest with you, I don't know that. So I'm going to use a pink pen to write it in because I don't know. When they ask in the interview room, I don't know. Okay. Te ions plus electron goes to tellurium. That I probably could have worked out if I sat down and really thought about it. So that is my own fault for being a little bit lazy. Part D, state the MZ value of the ions that produce the biggest current at the detector when the spectrum, I'm going to say 128 because it's most abundant. Because at the end of the day, it's still going to be the same equation for all of them, but if it's 7 versus the others, big boy energy. Look at that. I managed to get that question correct. So part E, the mass spectrum also had a small peak at 64. 64, 64, 64, 64 times 2, guys. 128. So that means we've had fragmentation because this is what? An electron gun? Yeah, that makes sense. Where's my pen? So this is a question I need to email my teacher about because I thought that would have been a fragmentation one. So atomic structure. Who taught me atomic structure? Which teacher taught me atomic structure? Oh, yeah, I know who taught me atomic structure. Atomic structure. Question 2E. Because these people are saying it's to do with ions forming. So, like me personally, I wouldn't have said it had anything to do with ions. I just said it's to do with fragmentation. Predict whether the atomic radius of 124 is larger than or smaller than. They're going to be the same. Why? Because their nuclear charge, strength, and the number of electrons they have don't change. It's the number of neutrons that change, right? I'm saying right, like you guys, I don't even know if you guys have done A-level chemistry, but you can't even respond, and that's the thing. Same E minus and P plus. That's why. Question 3. Okay, I'm getting into the zone a bit more. I've not done any chemistry questions in a while from this topic, as you guys can tell. Very, very rusty. Out of 12 marks, how many did I get? So E and C I didn't do. That's 1 mark lost. That's 3 marks lost. So that's 9 out of 12. This one is -2. This one is -1. Everyone else gives me the marks. Gorgeous. Let's have a look at this one. Pregunta número 3. Use a periodic table to deduce the full electron configuration. The full. Where's calcium? Is calcium a big boy? Calcium, that's long. SPDF. Calcium is in S block, so it won't be too bad. And we're looking at 20 electrons. 1s2, 2s2, 2p. How many do we have? We have 10. Okay. We already have 10 electrons written down, so I'm not as upset as I could be. That's 12 electrons. That's 18 electrons. 20 electrons. I don't know why I'm so exhausted from drawing electrons. It's so many electrons, you guys. So many electrons. Thank you, everyone, for studying with me, and thank you for all the thumbs ups as well. Okay, part B. Write an ionic equation with state symbols to show the reaction of calcium in excess water. That's a different chapter as well, but okay. It's ionic equation. Right, let me just write down ionic equations because me personally, and half equations, to this day, I'm still very, very confused. You know what? Let me have a quick snack, you guys. My sister makes these gorgeous brownies, but like I can't eat too much at once because they're so rich. So I'm gonna have a little bit of brownie and then keep on going with these questions. It's so sticky. Okay. That's the energy I needed to continue with these questions. I think it's just honestly counting electrons all the time. You're so smart, chemistry. Okay, thank you. Oh, I'm trying my best. Okay, question B. Maybe one more bite of the brownie because I'm just feeling very drained. Calcium is a metal. Let me write this down. Calcium solid. Don't forget your state symbols. It's excess of water, so it's going to be 2 lots of H2O. Goes to Ca2 plus, 2OH minus, and H2 gas. Allegedly. The 2 plus is going to be aqueous. The OH minus is going to be aqueous. How many marks is this one? 1 mark. So for this is going to be a -1 mark because I still get confused by them. I still get very confused. Okay. Also, do you guys like my new water flask? I really, really like it because I'm always cold. So it's always full of green tea. I haven't tried any other tea in here, but it's very nice. Like in my lessons where I'm like, yo, I'm getting tired, but I have tea. So that's fine. Very irrelevant, but okay. I'll do some stretches and then I'm less tired. Whoop, whoop. Let's keep on going. Thank you for the thumbs up. Oh, wow. That's a lot of thumbs up. Part C. State the role of oxygen of water. Let's write down oil rig. Even at A level, we gotta write down oil rig. Oxidation is loss, reduction is gain of electrons. This is oxidized. Wait, the calcium loses electrons. So the calcium is a reducing agent, therefore the water has to be the oxidizing agent. What's my spelling doing today? Okay. Write the equation to show the process that occurs when the first ionization of calcium is measured. So we're in gas state, right? I've not written the first ionization energy in a long time. Yay, at least I got it right. Boom. Bish, bash, bosh. We got the first ionization correct. I remember when first ionization used to scare me. Those are the days. State and explain the trend in first ionization energies of the elements across group 2. Down a group. Wait, across a period it increases, but down a group it decreases. Because we have more shielding. Whoa. My gas symbol has gone into the bottom line. That's making me a bit nervous. So more shells, therefore weaker attraction to ion of electron. Okay, first page done. And that is the end of that question. That question is out of 7. And in that question, I got 6 out of 7, which is all right. It's all right. This is question 3 out of 15, I do believe. So we're making our way through chapter 1. An okay pace. I think I'll start speeding up the more comfortable I get with this topic. A sample of sulfur consisting of 3 isotopes has a relative atomic mass of this. The following table gives the abundance of 2 of them. Use the information to determine the mass number of the other one. So 100, take away 1.8, take away 91 is equals to 7.2. So the relevant abundance of that one is going to be 7.2. That's good to know. This one is 33, this one is 32. So this times this plus this times this, let's write it out algebraically. 7.2x plus 32 times 91 plus 1.8 times 33, all divided by 100, is equals to 32.16. Now that it's written out, it's easy to see. So 32.16, that's divided, so times 100, boom. And then take away 1.8 times 33, take away 91 times 32. So 7.2x is equal to 244.6. So divide that by 7.2. Therefore, x is equals to 33.97. Do we round it up to 34? That's the real question. Do we round it up to 4? I'm just going to round it up to 34. I don't feel good about rounding it up because in chemistry and biology, the rounding is so different to in maths, and I feel guilty for breaking the maths rules. 1, 2, 3. I mean, it's still 3 sig fig technically. Describe how ions are formed in a time of flight mass spectrometer for 2 marks. Ions are formed, well, it depends, it's electrospray or electron gun. So they're fired with high energy, high speed electrons to knock out a thing. Oh, so the marking will accept either one. So I would say bombarded with high energy electrons, the molecule loses an E, becoming ionic or forming ions even. Part C. So this question, a time of flight mass spectrometer can be used to determine the relative molecular mass of molecular substances. Explain why it's necessary to ionize these things for 2 marks. So it's necessary to ionize them so that they can be attracted to the plates when they drift, and then obviously different speed shows their mass. The light ones will get there first, the heaviest ones will get there last, and abundance will equal a higher MZ charge, I think. Okay, so let's write that in pink because I don't know what they want me to say. Ions, not molecules, interact with electric field, and only ions create current. when they hit the detector. Lovely. So that's 2 marks that I didn't get, and it's out of 8, so that is 6 out of 8 marks. I mean, it's all right. It could be better. We're 1/3 of the way through chapter 1 of A-level maths exam questions, so that's lovely. Question 5. Is this 15 questions? Let me just check. I don't want to disappoint myself. Okay, 14 questions, even better. So we're further than we thought. Okay. This table shows some data about fundamental 1 over 100 and 1 over 1,840. How do I still know that? Okay, A, part 1. An atom of hydrogen can be represented as 1H. 1H. Use data from table 1 to calculate the mass of hydrogen. It's got... Wait, what does 1H have to do with anything? That's a real thing. I don't understand what they're saying. Why do I need to know the mass of a piece of hydrogen? A piece of hydrogen? An atom of hydrogen. 25 plus 9. It's 1 proton and 1 electron, yes. Wait. I'm getting confused. It's definitely 1 proton and 1 electron. Okay. Hydrogen has no neutron, just triple checking. But obviously, deuterium and tritium, they do have neutrons. Just got to be sure. Don't want to make any mistakes. We're not making mistakes today. I mean, we are making mistakes. That's how you learn, but still. And the lighting is getting better. That's lovely. So, next question. Which one of the following is a fundamental particle that would not be detected by an electric field? B, obviously, because it has no charge. Come on, guys. There's no charge. Okay, a naturally occurring sample of the element boron has a relative atomic mass of 10.8. We have B10 and we have B11. Calculate the percentage of calculate the percentage abundance of 10 boron in this naturally occurring sample of boron. Come. So 10x plus 11y over x plus y is equals to 10.8. So 10.8 times x plus y is equal to 10x plus 11y. You know what? I'm not going to even do it over x plus y. I'm going to do it over 100 because it says percentage. So 10.8 times 100 is equals to 1080. So 1080 equals 10x plus 11y. I spilled some tea on my paper. That's really sad. That's really, really sad. 1 second. Let me break this up. In fact, instead of multiplying by 100, 10x over 100 plus 11y over 100 equals 10.8. So then when we move everything across, but we can substitute y is equals to 100 minus x, can't we? So 100 minus x times 11 is going to be 1100 minus 11x. So on this side, we now have 10x plus 1100, and then minus 11x, there we go, is equals to 1080. And then from there, that's my 1 hour timer, yay. Repeat, I think I'll do 1 more hour of studying and then we'll go. Sorry, my headscarf is giving me a headache. Ooh, it's way too tight. It's a tension headache. That's why I can't think, because it's too tight. Right. Let me just click my neck because my head is actually really, really hurting. Should I blame it on the electrons? Correlation is not causation. But yeah. Let me just take off this headscarf. My head will be cold, but my head is really hurting. I don't even know why my head is hurting so much. Let me put my hair into a bun. A nice little bun. I mean, at least my hair's not too messy today. Just in some flat twists. Okay. Taking off the headscarf has helped a little bit. Don't know why I have such a tension headache. Ooh. And I've just had some green tea as well. Let's just keep trooping on with the questions and see how we end up. Oh yes, so this is plus 1100. So 1080 take away. So negative 20 is equals to negative 1x. So x is equals to 20. So it's a 20%. The fact that that took me so long is really embarrassing. Next question. Why am I feeling so tired? My chest. Okay. State in terms of fundamental particles why they have similar chemical reactions. They have the same number of electrons, and that means that they react similarly. That's the only thing that you need. Period. Okay. Let's see. Complete table 2 by suggesting a value for the third ionization energy of boron. What group is boron in? Where's my lovely periodic table? Let's see how charged we are. Oh, and we're not even dead yet. 86%. Okay. Boron is in group 3. Oh, no emails here. Boron is in group 3. So, oh, my eye. Sorry. The jump is going to be between group 3 and group 4. So let me just say kJ mole minus 1. That's a decent number, is it not? Let me search up how does provide evidence for cells. CCEA. I mean, it's not AQA, but let's actually go to the student room because I don't want to download a PDF. I need to look at a graph. I feel like a graph would just help me understand this more. Here's LG. What is this? Ionization. This is carbon. Carbon is in group 4. 1, 2, 3, 4. Is carbon in group 4? Let me just check. Carbon is in group 4. So 1, 2, 3, 4, and then we jump because we're going to a lower 1, 2, 3, 4. We jump. So we jump after the. Okay. Just checking. I feel like I look like a coconut now. The headscarf gives my head some dimension, but now we're just. Okay. So part D is write an equation to show the process for the second ionization energy of boron. This is nice. If you tell me to write an ionization energy minus, oh my gosh, I almost said an electron had a positive charge. Am I that tired? Period. We're getting marks. We're getting marks, honey. Okay, and then question E. Explain why the second ionization energy of boron is higher than the first ionization energy of boron. And this is because this time an E is being taken from an ion, a positive ion. So more energy is needed. How many marks is that question? 8 marks. Oh, I'm a bad B. 8 out of 8. One sheet finished. Ooh, okay. Now let's move on to question 6 out of 14. We're almost halfway through. You know what? I think I'm going to do atomic structure and then we're going to finish it. We're going to finish this topic, this live stream, because I'm actually, you guys can see I'm making silly mistakes in year 12 content, so I'll just have a nap. Hello, Angie. I'm actually studying AS chemistry at the moment too. Currently doing topics 7 and 8. I've done organic chemistry for the past 3 months, 4 months. I need to look at physical chemistry. But yeah, 7 and 8. You AQA as well, because I'm thinking chapter 7 and 8 is like redox, and chapter 8 is like inorganic chemistry, definitely. And I don't think we don't do topics in AQA, we do the chapters. We don't even have, I mean, we have sections, but we have 6 sections because we have physical AS, inorganic AS, organic AS, physical A2, inorganic A2, organic A2. Biology is the one that has topics, but not chemistry for AQA at least. Or maybe in your school they put it into topics. Anyway, I'm thinking about that too much. Question 6. Nickel is a metal with a high. I didn't even turn on my Pomodoro timer. Sorry, I thought my mom was calling me. I was trying to listen. It's completely left. Is there any point in putting on another Pomodoro? Sorry, I'm trying to hear. Am I being called? No, she's going downstairs. Sorry, guys. I'm listening outside as well. Like, I need to clean my glasses. You know what? Just put on a Pomodoro. I'm upset that I studied and I didn't time myself studying, so I can, increase my flip score. But yeah. Let me clean these glasses. I'm squinting. It's not because I'm staring at you. It's because I'm struggling, guys. I'm struggling with my glasses. Okay, let's continue. Oh, I think, no, this is from cooking. I've gotten something. I'll clean these properly after, because this is not the point of this live stream. Is it decent enough for me to see? It's decent enough for me to see. Question 6 out of 14 in atomic structure. All of the questions from 2012 to 2015. Right, we're doing nickel. State the block in the periodic table. I don't know. Let me look at my periodic table. Where's nickel? I love how when I'm not looking for elements, I just see them, but when you're looking for it, it's gone. Okay, it's definitely not S block and it's not F block. So it's either P or D. Worst case scenario, if I don't find it, we guess. This is P block. Look very carefully. Oh, there we go. It's in D block. Where's SPD? I like the way that the periodic table is actually organized. I mean, there's some elements that upset me. I think germanium should not. Which one is it? Germanium and CN. I don't even know what CN is, but those two really upset me. CN. Where's the RG? Where's RG? Oh, it's not even in the A-level periodic table. So, yeah, germanium. It's a bit suspicious. It's like, I don't know if you can see how this is color coordinated, but it's the wrong color. Those two are the wrong color, and I'm just like, it should be the right color. Obviously, the color indicates what type of element it is, and I know that you can't change the type of element it is, but I'm just like, suspicious periodic table. Aesthetic periodic table. But let us continue and not be distracted. Explain in terms of structure and bonding why nickel has a high melting point. Nickel, structure and bonding, 2 marks. It is a metal, so it has metallic bonds that require a large amount of energy to, So yeah, so positive metallic ions and delocalize. I'm tired of delocalized electrons, especially in benzene. Electrons and strong attraction between metallic bonds. Yay! Oh wow, the mark scheme said you're allowed to draw, but nah, you guys are nah, that's childish. I really wrote out a whole. And you told me I could draw. If you told me I could, I would have drawn instead of using my. Look, let's just draw 6. Uh-oh, that should be touching. Let's have 6 particles. These are positive, and then we can put some electrons around them. Make it nice. Yeah, let me come back to the chat to see. Hey guys, checking in on you again. Now, part 4. Explain why nickel is ductile. Because there are layers that slide over one and the other. That's a good song, I think. I think it's like Pop Smoke. Yeah, it's like a remix with like a bunch of musicians on it. When we go slide, but not musically, just metallically. Metal sliding. Okay. Nickel forms a compound nickel 2 chloride, NiCl2. Give the full electronic configuration of the Ni2 plus. 2 plus means we've lost 2 electrons. We have that periodic table. We have 28, 28, so we have 26. The full. You guys want me to write all 26 electrons? You're really acting SPDF. You're asking for a lot. 1s2, 2s2, 2p6, 3s2, 3p6. Let me just count now. 2, 4, 6 times 3 is 18. How many electrons am I drawing? I'm drawing 26 electrons. I'm tired. I don't want to draw any more electrons. I'm tired of drawing electrons. 3d8. Is it? Wait. 1, 3. 1, 3, 5, 7. 1, 3, 5, 7. So this could take up to 10. But 18 plus 8 gets me up to 26. Okay, I've counted my electrons, and I've drawn all of the electrons I need. Drawing electrons and drawing hydrogens is going to become the bane of my existence at this point because there are just so many for no reason. Okay. Balance the following equation to show that anhydrous nickel 2 chloride can be obtained from the hydrated salt using SOCl2. Balance the following equation. So I always do a little table, left-hand side and right-hand side. So we have nickel. It's like a two-way table. We have Cl2, we have H2, and we have oxygen. So let's tally. We have 1 nickel here, 1 nickel here. 1 Cl2, 2 Cl2s, but 1 Cl2 here. So this one I'm thinking we have to put 2 here. Let's say we put 2 here, then we have to put 2 here, then it doesn't add up anymore because then we have 2 nickel, but then we have 3 of these and 2 of these. So that's going to be my problem. That's going to be my problem element. If I make that 3, no. The number on that has to be the same as the number on that. How do I deal with this? Because the sulfur is the same. The oxygen is the same. How many hydrogens do we have? 1 hydrogen here and 12 hydrogens here. Is that, oh, it's hydrated. So even better, even more maths. Identify one substance that could react with both gaseous products. What's going to react with both gaseous products? What's reactive? Who wants to react with sulfur dioxide and HCl? This is really upsetting me at my home, guys. I'm going to email my teacher about this. Question 6. B. I. Let me look at the mark scheme because how am I meant to balance this number of nickels? That's the real question because it's not something I can balance very easily. You put 6 here because then you have 1 nickel, 1 nickel. You put 12 here. Oh, there's a Cl over here. That's why I didn't look at all the Cls. So it's NiCl2. Okay, I won't email my teacher about that one. That's just me being silly. Plus, oh, no, it's hydrated, so 6H2O. Plus 6SOCl2, which goes to NiCl2 plus 6. I feel so silly for not getting this. I'm quite embarrassed. That's -1 mark, is it not? Yep. And then the next one is NaOH. Why would that react with all of them? Sodium hydroxide. Why is sodium hydroxide reacting with sulfur dioxide? I feel like this is an inorganic topic that I should know. Sulfur dioxide and sodium hydroxide. It's an absorption thing. It's flue gases. I knew it was flue gases. Okay. So this likes SO2 because flue gases. But why HCl? Why are we reacting sodium hydroxide, NaOH, and HCl? It's the fact that it's testing me on other topics as well, and I'm just trying to revise one topic at a time, but I guess that's not possible. HCl and sodium hydroxide makes water and salt. Oh well, obviously, I think it's the fact that my head is thinking just one chapter, but you have to just think the whole spec for making NaCl. Okay. Oh, I'm feeling very down about that question. That really hurt. That question really hurt. Anyway, now we're halfway through. How long has it taken us? Oh, 56 minutes. But we're speeding up at least. So how many marks was that question? That really made me sad. 7 out of 9. Not bad, but still. Could have been better. Question 7, let's have a look. Define relative atomic mass. The relative atomic mass is the X bar, so the mean mass of one atom relative to 112 of C12. Why did we even choose C12 in the first place? That's the question I ask myself often. Oh, there's element X. Do I really want to be doing element X? I've seen too many graphs in my life. I'm sounding like I've been hurt by the graphs, but some of them have. Okay, use data in the diagram to calculate the relative atomic mass of X. Do this to one decimal place. 3, 4, 9, 14. So it's going to be over 14. And that's going to be 70 times 3 plus 73 plus 72 times 4 plus 74 times 5. Lovely girls and boys. And what is the answer? The answer is going to be 72.4. Bob, is it over 14? No, it's over 13. Come on, babes. We can do better. Okay, then part C. Is it over 14 or 13? 3, 4. 4 plus 9. Come on, babes. We can do better than this. Huh? Yeah, I'm on question one decimal place. Yeah. Identify the ion responsible for the peak at 72. It just says X. Wait. Let's read the question again. Identify the ion. So it's 72. So we need a periodic table for this. So that could be germanium, the element that haunts me. So I'm going to say it's germanium plus. So 72 germanium plus. D. Question D. Now that question 6 actually really made me feel sad. Okay. Identify which of the following isotopes X is detected the most by the magnetic field. 74, because it's the most abundant. Wait, did it say most or first? Which is going to be detected most? Most should be the most abundant. And this one says lowest mass. So it's actually question 7. D. No? Yeah, D. because that question I do not know. I hope you guys are productive where you are as well. Okay. Whew, this is rough. Let me have another bite of the brownie and some more tea to like give me the energy I need to get through this. That was a really big bite. Also, it's gonna sound so weird, but in the morning on the train when it's really hot and I first open this, really hot, really cold on the train, but this is hot. It's very therapeutic because I study on the train as well. But anyway, in a mass spectrometer, the relative abundance of each isotope is proportional to the current generated. Yeah. Current is generated because the ions, wait, Q equals IC, it's to do with the charge. The ions pick up electrons, do they not? And that's the flow of electron. We've created a flow of electrons, and that is why there's a current. We're making currents. That's what we're doing today. Okay, these are different elements. Explain why the chemical properties, different electron configuration. I hope my sister knows I'm live streaming. To the text her to say. Thank you. They have a different number of electrons. Question 8. Don't get me excited. Do not get me excited. We're almost done with the tonic structure. One down, 33 chapters to go. A-level chemistry is long. Okay. Aluminum and thallium are elements in group 3 of the periodic table. Both elements form compounds containing chlorine and bromine. Compounds and ions containing chlorine and bromine. Write an equation for the formation of aluminum chloride. So we have Al and then we have Cl2. If it's in group 3, and that one's in group 7, 1, 2, 3. I'm going to say it's AlCl3. So divided by 2 times 3. If I got that correct, I'm going to be very, very happy because that required a certain level of maths. Come on, don't play with me. I got the mark. Oh yeah, what did I get for question 7? I didn't total it up. Question 7 is out of 11. Part B is 2 marks, so 9 out of 11. I mean, it's upsetting. It's upsetting to me and my homegirls, but 9 out of 11 is better than nothing. An aluminum chloride molecule reacts with a chloride. You guys are you're not slick. You want to link to chapter 28, and we're in chapter 1. AlCl4 minus is used in electrophilic substitution of benzene rings, right? Yeah, it is. Ew, yeah, it is. Okay. Name the type of bond formed in each reaction. Explain how the bond formed in the... Okay. There's going to be some kind of dative bond, right? That's what I'm saying. I'm guessing it's dative. From Cl, but that doesn't make any sense. Does it make any sense? Yeah, it does make sense. Dative as a pair on Cl minus donated to AlCl3. See, I don't know why. I don't know how, but it's the correct answer. Should I think about why? Okay, so I've got my lovely aluminium. I've got 1, 2, 3 electrons. Then we have 3. Oh, my hair's still wet from anyway. 1, 2, 3 electrons from chlorines, which have 7 in their outer shell. And then chlorine, it's minus, so that means we have an extra electron, right? So we have 2 chlorine here to make a lone pair. Then we have 5 here, and that one doesn't have a bond, which is why it's charged, and it's Cl minus, Cl4 minus. Okay, so now I can explain it at least. I just felt that in my gut. I was like, it has to be a dative bond. I don't feel a lot in my gut about chemistry, but that's one thing I felt. Aluminum chloride has a relative molecular mass of 265 in gas phase. Deduce the formula of the aluminum compound that has a relative molecular mass. Wait. That question didn't make any sense. Wait. Wait. Let's do the maths. Where's my periodic table? I keep saying wait. I'm trying to follow this. We're looking at the mass, right? Not the... Yeah, we're looking at the mass. So that is 27 plus 35.5 times 3. So you double it. So you have Al2Cl6. See? Do not play with me. I'm a chemist. I'm actually a chemist, you guys. Okay. Thank you for all of the thumbs up and everyone who's come to watch. We're almost done now. I'm getting excited. Okay. Part D. Deduce the name or formula of a compound that has the same number of atoms, electrons, and shape. Ho, 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 ho. Deduce the name of the formula. The first thing to do is always to draw the structure. It's a good habit. So let me get a blunt pencil this time because that's how I'm feeling. So AlCl3. Al is here, and we have 4 bonds. So it's going to be tetrahedral, right? This is coming out of the page. This is going backwards. That's Cl, 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 Cl. Do I put an arrow here because it's dative? Because that's what I'm feeling like. 1, 2, 3, 4, 5. One more time. Let me read this question again slowly. Más despacio because I'm not following this, babes. Deduce the name or formula of a compound that has the same number of atoms and electrons. Same number of electrons. Let's count the number of electrons involved in AlCl4. So Al, that's 20, nope, that's 13 electrons. And then Cl4 minus, that's 17. 17 times 4 electrons. So we're working with 81 electrons. How do we get to this point? It's trigonal bipyramidal. Cool. Wait. Well, that's a different, no. SiCl4 instead of AlCl4. Where's Si? It's right next to it. I'm very, very confused. What question is this? Is this question 8 or 9? This is question 8. It's making me sad. Question 8. Part D. Because it's very, very confusing. Rithik, Raja, I'm up to be my remember to the other side. Also, what you need to do apply to. Hi, Rithik. Yeah, I did it at home, like a lot of people. And what you need to apply to. I feel like I have a video on this, but I have to actually think about this. I'm like, it was so many months ago. It's not December. Leicester, Sheffield, Imperial, King's, Oxford, some US unis on the top of my head. So the live I did like a year ago from now no longer applies because I was going to apply to study in other countries as well, on top of UK and US, but the pandemic, the virus that shall not be named, that messed up plans because everything went out of place. But yeah, so back to the ALCL4 that's been getting on my nerves. Right. TL BR5 2 minus. What is this TL? Is it tellurium or something? Oh, it's thallium. Okay. But it's in group 3. So you have 3, you have 1. Oh, 1, 2, 3, 1, 2, 3. And then you're going to have a dative pair as well. Oh, 1, 2, 3, 4. Oh, but it's 2 minus. So there's some extra electrons. But where are the extra electrons coming from? I don't know where the extra electrons are coming from. This is part E. It's BR5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You have only 3 electrons for yourself. So where did the 2 electron pairs come from? Is there just an extra one because it's 2 minus? It's part E as well. You're I'm very confused. I know it. Let me just finish these questions because now I'm getting upset by the molecular geometry, even though I'm sure this is meant to be atomic structure, but there's so many molecular geometry questions. It's a little bit suspicious. So the shape of a TlCl2+. Okay, thallium, that's group 3. This is group 7. Okay, my Pomodoro has gone through. Lovely. I should have a break now, actually. But it's Cl2+. So the Tl is going to be in the middle. Plus means that it's lost an electron somewhere. So instead of because then you make 8. You make 8. But you, my friend, you've only got 5. This whole question is just giving me stress. E, F, and G. Question. Personally, I think we should just get entirely. I don't think question 8. At least I know that I can do it. Question 9. This number of isotope is the number of protons and the number of... It's the number of nucleons. Why am I saying protons? Nucleons. Nucleons is such a strange spelling. Anyway, not my periodic table. B. Give the symbol of the element that has the isotope with the mass number of 68 and has 38 neutrons. Okay. I thought I heard something. Periodic table. Wait, it's an isotope with mass 68, 38 neutrons. This mass is 66. So if you add 2, it has to be zinc. I don't care what you say. It's not gallium. It's not germanium. It has to be zinc. It's gotta be zinc. Okay. Okay, part C. What is this, my friend? That's a mass spectrometer. The following shows a simplified diagram of a mass spectrometer. High mass spectrometer. State what happens to the sample parts labeled P and Q. Oh, in these parts. Oh, so it becomes ionized here because that looks like a high voltage, high energy, whatever. And then part Q, where's part Q? Babes, I don't know because I can't tell what's going on in this diagram. Like, I cannot tell, unfortunately. I'm not following at all. Faith, who you a student trying to study? What's happening in part Q of my detector? Acceleration, okay. Is that just like a process of elimination type of thing? Because I wouldn't have guessed that was acceleration at all. I wouldn't have guessed, not even. Not even a little bit. Let me get myself a tissue. I need some more tea as well. But I don't know how you're meant to tell that it's acceleration. That's the real question. If I showed you guys this diagram, you'd be just as confused. It looks like a boomerang, but chemistry. Okay. Uh-oh. I'm making a mess on my desk. I actually want to have more of that brownie, but I know I should just wait, finish what I'm doing, and then celebrate with a brownie. That's the best thing to do. Okay. Then, next part. In a mass spectrometer, the isotopes of an element are separated. 2 measurements are taken. State the 2 measurements. The speed, the velocity, and the mz, right? Mass and charge. I don't know. I just know it's mass and charge. Is that 2 separate things though? Because you do mass over charge. So those are the 2 things. Mass and charge. Okay. Part D. Okay, why do I keep getting little error messages? Oh, it's atomic structure. NB205. Okay. Yeah, so back to the question. Part D. A sample of element R contains isotopes with the mass numbers of 206, boom, and 207 and 208 in a ratio of 1 to 1 to 2. So if we're doing sigma in the corner, that's 4. Calculate the relative atomic mass. Oh, that's easy. So that is going to be 206 plus 207 plus 2 times 208 divided by 4. So it's going to be 207.25. And then go over to the periodic table so that we can identify what this is. Can you tell me the positive ions and the negative ions? That's maths. Show me the paper. I'm not sure how to show you the paper. But positive ion, there's no positive ions or negative ions in this one because this question is just to calculate the relative atomic mass and then identify what R is. So if we have a relative atomic mass of 207.25, oh, I found it. I think it's lead. It's probably going to be lead because lead is 207.2. So it might just be like some type of, like there's just a discrepancy between the isotopes that we used or the numbers that we used, etc., because 1 to 1 to 2 is quite simplified. All the isotopes of R react in the same way with concentrated nitric acid. That's because they have the same electron configuration. Boom. Then question 10 out of 14, we're almost done with this booklet. I'm very, very tired, guys. It's a very long booklet. Okay, too, thanks. Yeah, when I work out how to like show what I'm doing on screen, that'll be even more fun. Because then we can work through the questions together, which would be really nice. Or depending on what you think nice is. Element of rubidium has isotopes 85 rubidium and 87 rubidium. State the number of protons and neutrons in 85. Protons, neutrons. Where's my periodic table? Where's my rubidium? Is that the mass number that we're looking at? Because I cannot see it anywhere. There we go. That's my rubidium over here. So 85 take away 37 is 48. Boom. And that is a decent number for question 10. Is that correct? 3748. Lovely. Part B. Explain how the gaseous atoms are ionized. Well, that's going to be electrospray then, or is that going to be electron gun? If it's, wait, everything has, yeah. High energy and high speed electrons knock out other electrons. Lovely jubbly. Okay, part II. We're getting closer to the end. Okay, write an equation including state symbols for the first ionization energy of rubidium. This goes to, this is nice and easy for my rubidium. I don't even need to check the mark scheme because, oh, I didn't actually count up how many marks I got for question 9. Question 9 was out of 11, so 11 out of 11. That's nice. For once, we're doing a bit better here. 11 out of 11. But overall, this has been a good recap for this topic because I've completely forgotten about it. Okay, question 11. The table shows first ionization energies of rubidium and some other elements in the same group. 1. This is group 1, right? State one reason why first ionization energy of rubidium is lower than in sodium. Let me look at this. Because there's more shielding, right? So E are further from the nucleus, therefore less attraction. And this is S block. I'm not writing the full configuration. I'm so sorry. I've done this so many times today. It's not happening. I'm tired of doing the full configuration. I'm very, very tired of doing first configuration. In one experiment, 0.558 grams of X reacted with Y to form Z. How many grams of Z were formed? I'm not sure. If it's a closed system, that might change it. I don't know if Z is a gas. I want to assume you just add the two together. So that would be 878. But I'm not. I feel like that makes sense, but I don't know if it's a closed system. It says only one product, so that's what I'm going to assume, but I'm not actually sure. But yeah, back to question E, because I'm not writing the electron configuration. A sample of rubidium contains these two isotopes. So isotope RB5 has an abundance 2.5 times greater than RB7. So that's actually only 3 marks, and that's such a nasty question. So let's just say it's 2.5 and 1, because there's no need to overcomplicate it. And then we get 85.6 as our answer, which is awesome. And then I sub, thank you, for point F. By inference, what part of the spectrometer, wait. What is determined? Okay. It's the detector, because high current equals high abundance. Boom. And then for question G, I'm getting tired, but at least we finished question 10. So we have only 3 questions left before we can call it quits and finish these questions. I'm going to come back to that question in a second. Let me finish the questions that I'm doing. Question G. Where's the question paper? Predict whether 88SR will have an atomic radius larger or smaller than RB87. Where's my periodic table? We're looking at strontium, right? Okay. It's going to be smaller because same shielding, but higher charge or nuclear charge. Okay, guys, we're getting to the final countdown, the final 3 questions. I'm very tired. How long have we been live streaming? 1 hour and 24 minutes. 124.3 grams of magnesium reacts completely with 16 grams of oxygen. Exactly. I feel like I need to write this down on a sheet of paper. Okay. So that we can follow what's going on. So MgO2, MgO. Look, this is a -2. This is +1, so we're going to need 2 lots of this anyway. And then we get MgO. Okay, mass, molar mass, number of moles. Mass is 24.3. Mass is 6. Oh, those are nice numbers. Those are actually nice numbers. 40.3. Do some quick maths. Yep. Emma is not going to be relevant. Oh, I didn't even read the whole question. I started writing it out. It's not even a calculation. Law of conservation. You can't randomly make more stuff from nowhere unless it's like not a closed system and there's more oxygen coming in than the 16 grams you mentioned. I was really writing it down thinking I had to do calculations. Okay, back to the questions. Question 11. Use your knowledge of electron configuration and ionization energies to answer this question. The following diagram shows the second ionization energy. Draw an X for the sulfur. It's SA and P4, so the ionization energy is going to be bigger. Okay, then I'm not writing a full electron. No, I'm not doing it. I'm not writing the configuration. Write an equation to show second ionization energy. Once again, I'm tired. I'm not doing it. Why the second ionization energy of silicon is lower than aluminum. Okay, I'll answer that question because the other questions are just trying to upset me. So silicon is removed from a 3p orbital, which is a higher energy level. Yeah, that's 3p. Yeah. I hope the lighting isn't too bad on you guys' end. It doesn't look terrible from this side, but it may be misleading again. Okay. Right. Thank you for all those thumbs up. That's really, really nice. Let's have a look at part B. Predict the element with the second highest ionization energy in period 3. What, period 3? Let me open period 3. 2p. This is question 11. Baby. Oh, I'm going to see my teacher on Tuesday. Okay, that's good. Question 11, part B. I just don't want to read the rest of the question. That's the rule. That's the reality of it. This is very confusing, right? Question C. What element is this? 1, 2, 3, 4. This is in group 4 and period 3. So this element has to be dun dun dun. Silicon. Wait, I said period 3, right? 1, 2, 3. Period 3, group 4, silicon. Am I correct? Of course. Look at that. I can interpret data. And then part D. Explain why ionization energy is endothermic. I don't know actually. How many marks is that? That's only 1 mark. So this is another -1 mark over here. So that means that I've gotten 6 out of 8. Unfortunately. Let's write the answer in a different color. Okay, we need energy is needed to overcome attraction between positive nucleus and negative E. If I applied myself, I probably could have gotten that question, but ooh, question 12 is looking a little bit. Bell Jones, hi, and then Lollipop 98, hello. Question 12 out of 14. Very, very excited. And we'll see what mark I get at the end. I'm quite excited. I mean, I'm not that excited because I've dropped quite a few marks, but for year 12. Workbook. Okay. The manufacture of food grade phosphoric. I don't want to do this. I don't want to do this. How long is this question? Ooh. Okay, it's only part D. Okay. Right. If I don't like it, I'll just skip the question and come back to it. It can't hurt me. It's just chemistry. The manufacture of food-grade phosphoric acid for use in cola drinks began with the production of pure white phosphorus from the mineral fluoroapatite, Ca5F, open bracket, PO4, close bracket 3. I could be doing a humanity, but we're doing chemistry. Could be writing essays, but I'm trying to do maths. Complete the following equation for the manufacture of phosphorus. Okay, let's draw a two-way table. You know what, not even a two-way table. This time I'm just going to count the number of electrons we have on each side. I'm getting tired, you guys. It's been 90. Typically after 90 minutes is when I need to take a break. Because unless I'm planning to do like an 8-hour stint and it's just a casual Saturday of studying, there's no need. Absolutely no need. Okay, we have calcium, we have fluorine, we have phosphorus, we have oxygen, we have silicon. Way too many elements, first of all. Way too many elements. So on this side, we have 9, 10. So that is a fixed thing. So this number has to be 2 because we have 10 calciums in total. Lovely. Then our number of phosphoruses is 6 right down at the end because that is fixed as well. We have 9 oxygens times 2, so we have 20 oxygens in total. So that one has to be 20. Ooh, is that correct? But then if we have 20 carbons on this side, that means we just put 20 carbons on this side. Please be correct. 2, 6, that's correct. Not 20, 15. That's me doing silly maths. Okay. See, the question isn't as hard as you think it is. The question can't hurt you. The question can't hurt you. Okay. Part B. As the phosphorus cools, it forms pure white phosphorus P4, even oxidation state for P4 in the following. Well, it's going to be 0 there because it's a whole thing. And then this one, +3, -8. So +11, that's quite large for, I feel like it's going to be +5, is it not? I feel like it's going to be +5. I think wait, let's do it again. +3. I keep on clicking on minus. That's why. Yeah, it's +5. I was like, +11 is such a random. Sulfuric acid is manufactured from sulfuric acid and calcium phosphate. Use the following precise. I never remember. Don't say that. Positive. We always remember. Precise relative atomic mass. That is something I need to check the spec for because I do not remember. Okay, so use the following precise relative atomic mass data to show how mass spectrometry can be used to distinguish between pure sulfuric acid, H2SO4, and H3PO4. They both have an MR of 98. Okay, where's that pink pen? Because I know what. I know. Okay, so you do the math, you have 98.06. You do the math, you have 97.98. They're 2 different numbers. Great. Bob is your uncle. Okay. And then part D, the final part of question 12. Can I do any more? Push a little bit more. Concentrated phosphoric acid is used as a catalyst in the hydration of propene to form this alcohol, CH3OHCH3. It's the main organic product. The industrial name for this alcohol is isopropyl alcohol. Catalyst reduces activation energy but not used up. And it does this by going through an alternative route. I've written that so many times in my life that at this point, it's something that we've memorized. Let's check the mark scheme. Yep, chemically unchanged. And then the final part of the question, hydration means adding water. Okay. Because it looks long, I was like, ew, but it's not. Isopropyl alcohol. Give the IUPAC name. Do I want to give you the IUPAC name? Do you deserve the IUPAC name? The IUPAC name is it's propan-2-ol, I think. I mean, if I slow down, then I'll definitely get it right, but okay, there we go. Propan-2-ol. Does it want me to write an equation as well? Yeah. Hydration of propene. So propene is what? Let me draw propene so I can remember. That's double bond. So that has H, that has H. That already has 3 bonds. That's a H here. And then that one has, so that's 1, 2, 3, 4. That carbon has 4 bonds, that carbon has 4 bonds, that carbon has 4 bonds. Thank you. So CH3, CH double bonded to CH2. I sound so aggressive right now. And then plus H2O goes to that. I'm not writing out the final bit. I'm tired. Okay, 2 final questions, guys, and then we're going to be done with this live stream. It's been a very, very long one, getting through all of this topic. And to think I thought I was going to do so many questions in this, but my mind has been rattled, completely rattled. Okay, question 13 out of 14. Nitrogen forms this. What's a nitride ion? That's going to be N3 minus, but I'm not writing it down. Identify Q. Where's my periodic table? F minus. Okay, that's cute. Part C, use your periodic table to write lithium nitride. Li3N. Yeah, that's what it is. I got it right at least. Then part D. I clicked on the wrong page. Use your periodic table. You have done that. Calcium is 81%. Metal. Calculate an empirical formula, but I don't want to. Okay, 100, take away 81.1. So the empirical formula, that is 2 plus, that is 3 minus. So we need 2 of these and 3 of these. Nitrogen is 14. Okay, I had to think about that. 81.1 over 14.1. Then I have 18.9 over 14. And then that is 2.02. This is 1.35. And it is a 3:2 ratio. So we already, I don't know why I had to do all this maths, because you guys could have just told me to write the answer instead of proving it. It's always the proof, everyday proof. And in maths, everyone's asking me to prove things. Can I not just write out? I want to write the answer. Write an equation for each reaction between silicon nitride, Si, why am I writing this reaction? You already told me what happens at the end of it. So I was correct. Is it N2? Okay. That was just intuition. I'm not doing that. I'm not making another. Question 14, I'm so sorry. I'm so sorry. But I am not going to do that calculation at all. Okay. The relative atomic mass. Let me just count and talk through it. 2, 4, 7, 17. Do the whole thing, then divide it by 17, and then you'll get like 84 point something. Oh, let me look at the periodic table. Where's krypton gone? Where is krypton on the periodic table? I've looked at krypton earlier today. Where's my krypton? Why can't I see krypton? It's not S block. It's not. Oh, there it is. That's my krypton. Yeah, so it's going to be about 84, 83.8. Okay, part B of this question. Is that it? Oh my gosh, you guys, this is the final part of the question. This study with me is about to finish. Don't get emotional. I've not covered this topic since probably, I don't know. Actually, I think I did it over the summer. So September, summer, and now. And I'll probably do it again briefly. Oh, I spilled some tea on my desk before my actual A-levels in June. I think the first chemistry one is the 7th of June. We'll see. State how krypton is. Oh, a mass spectrometer question. Perfect. 5 marks. It's a long one, but these are the questions I normally get wrong. So this is a really nice way to end this study with me. 23 pages of questions. Your girl is very tired. Okay. State how krypton is ionized in a mass spectrometer for the first part. High speed, high energy electrons are bombarded. No, it is bombarded by them, which knocks. Oh, and look at that. My timer for 2 hours of studying repeats. Knocks out. What does it knock out? An electron. Write an equation for the first ionization energy. Kr in gas form goes to Kr plus. Are you guys proud of me? I don't believe I did all of these. Plus my electrons. And then sometimes the mass spectrum has a small peak with the MZ value of 42. Explain this peak. Is this another ion, like 2 plus? Period. It's a 2 plus ion. And that's 5 out of 5 marks in that section, which is 9 out of 9. Okay, let's work out how many marks I got in this. 9, let me get my calculator. 9 plus 24. Ooh. It's going to be what, 33? Then 33 plus 20, 53, plus 8, 61, plus 9 is 70. 70 plus 19 is going to be 89. So the total is 89 marks in today's study with me. So we got, let's put this in the calculator, 9 plus 9 plus 6 plus 6 plus 8 plus 7 plus 9 plus 16 plus 8 plus 9. What? 87 out of 89 marks. Something doesn't add up. Let's see how many marks I dropped. I dropped 3, 4, 5, 6, 7, 8, 9, 10. There we go. 11, 12. I dropped 12 marks. I don't know what's going on here. The 89 take away 12 is 77. Divided by 89. So we got 87% today, guys. It's all right for a year 12 topic. I hope you guys had a very productive study with me as well. I'm not sure what topic you've done, if you're watching in the playback or if you're watching right now. What exam board are you doing? I'm doing AQA. So we've done it. I've got my list of questions for my teachers. Normally I'd like start sending the email now, but I think I'm going to do a few more chapters later in the day, maybe. I am very exhausted and I need to have a lunch break. But yeah, later on, I'll write a lovely email to my teachers saying which questions I need help with. Yay! 1 chapter down, 33 to go. Very exciting, very exciting. Let me close these chemistry questions, get rid of that periodic table. Everything can go. Thank you, wonderful people, for joining me in this study with me. I hope you have an amazing day. And as always, smile, subscribe, study hard, slay hard, and I will see you again very soon. Bye.